as I was mentioning before, seeing them and just kind of practicing and being ready for them, I think is going to be really good preparation because I think as we begin to talk about them, these questions might be once again more about what vocabulary do you understand? Um, is it really that hard kind of thing? But definitely welcome to put any answer or any comments, questions, answers in the chat, or you can definitely unmute and we can talk. Okay, so you'll probably get a lot of questions like this, and you'll not only see this on like a GED math test, but you might also see it like the topic here. Um, you might also see this on a social studies test because it kind of has an economics kind of theme to it, but you might also see circle graphs on science or social studies as well. And so which statement is supported by this graph? And so hopefully you guys notice that the question is saying, right, that based on this information, right, one of these four statements is true. And let me see if I can get it actually. I wish it didn't do this. If I click here. Okay. So the statements are Americans spend more than half of their take-home income on housing and food combined. Okay. So housing is this pretty big wedge of the pie. If it's 33 cents out of every dollar that I bring home from work, is that more than half by itself?
It feels like it.
33 out of like 33 cents out of a dollar. Is that more than half a dollar if I have 33 cents? I mean, it's the biggest piece of the pie, but right, 33 cents, right, is the same as, right, 33% of $1. And so, right, so basically what this is telling us once again is this circle represents $1. Okay. And then, right, they cut that $1 up into all of these slices based on, right, how we spend that dollar. So take home dollar means the net income, right, that I get to take home after taxes. What do I spend it on? So 33 cents out of every dollar that I earn, I spend on housing. And maybe in Flagstaff, this number is probably higher. Okay. But the statement here says, right, more than half. So 33 is less than half, but it says food and housing combined. Food is 13 cents. 13 cents plus 33 cents is a total of 46 cents. Is 46 cents more than half of a dollar?
It's like half a dollar?
It's
Close to.
all, yeah, I mean, 50 cents, right, is half. 50 is
Yeah.
half. So, but it's not more than half,
Okay.
right? It's less than half. 46 is less than 50. It's therefore it's less than half. So you can kind of tell, or maybe not, I don't know. But like you can kind of tell that it's not a full half of the circle, right? It's just barely under a half of the circle. And so, in order for it to make up, right, more than half, those two pieces of pie would have to, right, take up more than half the circle. Okay. So, hopefully, you guys are seeing how to visualize. So, A is not, right, it's not supported by this graph. It is inaccurate. It's wrong, right? If we change more than half to a little bit less than half or almost half, but this statement here, not supported by this graph. So does everyone see how the question works? Because I'd be interested to hear why this one might have been so. And yeah, you can see some people chose that, and then some people liked the last one. I'm glad no one liked answer B. Let's take a look at this again. So then no one liked B, which is good. Americans spend more on healthcare and entertainment combined. So that would be these two little slices, 12 cents, compared to take-home income spent on food. And food is 13 cents, right? So once again, 13 is more than 12. So you're still spending more on food than both healthcare and entertainment. So that's not true. So not supported by the graph. However, right? Why is C the answer? Why does this graph support the statement that Americans spend about 17% of every take-home dollar on transportation?
Because it's a statement of a fact.
Um,
I mean, I don't really see any of the other ones supported by the
sure.
graph.
Good. And it's really the relationship. Wow, what a sorry. Like I want a big fat, like, oh wow, okay. That's not right. Um okay. As you guys can see, I'm not on my classroom computer that I can drive a lot more easily. But hopefully what you need to think about is the relationship between 17 cents and 17%, right? Because this circle represents $1, right? 1.00, right? It's the same as, right, a percent circle representing 100%. So you could think of a dollar as 100%, and all of these, right, numbers represent the percent. So this would be 11%, 3%, 5%, right? 33%. Okay. So so always think about that when you have your pie chart. What's the whole and what's the parts? Here it's $1 and the parts are, right, how do we slice up the change of the dollar, right? Because if I added up all my slices, I get $1. Okay. And so because of that, $1, 100%, it basically goes, right? 17 cents is 17% of a dollar because there's 100 pennies in a dollar. Hopefully I'm blowing your guys' minds. Just kidding. So hopefully that feels good. And then the last question, sorry. Of course, I wish I wouldn't do this. Sorry. All right. Let's see. Sorry. After covering basic expenses, Americans do not have additional take-home income to spend on other goods and services. So is there anything in this that shows that they are spending some of their money on other goods and services? And you could also think of like even clothing sometimes isn't necessarily, right, like a basic expense, although it doesn't really help us know which ones are technically basic expenses. But right here it's telling us, right, that 11 cents goes to other purchases. And we would definitely agree that like transportation, housing, food, and healthcare for sure would be like our basic expenses. Insurance is kind of a required expense, so I guess it has to go in there. But like entertainment and clothing, once again, and other, it doesn't tell us what other is. It doesn't tell us if it's like bills or what. So we would want to probably, once again, answer C is way more supported, right, than Um, we would probably say D is just, there's just not enough details to be confident. Like it doesn't not sound right and it doesn't feel right according to our own lives, but is it supported by this graph? Not really, if we have this whole big 11-cent piece of our pie. All right. Questions about number one? Thoughts? Is everyone feeling more confident kind of about what to notice? All right. Let's look at this one. Now, this is going to be something you'll probably see. I've seen a lot of these types of graphs. Now, this is a line graph, and this is kind of a special type of line graph in that you can see that, right, that there's two lines, so we can compare them, and hopefully everyone read it so that, right, and like I said, I really should have added some color, but hopefully I know you guys are super smart. Okay, I'm gonna try this again. Highlighter, there we go. Oh, that's what I was doing wrong. Okay, right. So this is the bicycle line. It's like this line right here. Okay. And so we have, right, we're comparing a bicycle to a car. Okay. And right, it looks like we're measuring it in minutes per mile. Okay. Of course, usually with a car, we would do miles per hour because we can, right, kind of have more speed. But with a bicycle, we might want to say miles per minute, right? So where this line, right, where kind of the points of the line form is, right, basically after 1 mile, how many minutes did it take to go 1 mile? How many minutes did it take to go 2 miles, 3 miles, 4 miles? Is everyone kind of seeing that? So if I was going to read this, right, I would know that in order for me to bike 3 miles, I should plan for it to take 14 minutes. Whereas, right, if I needed to go that same distance in a car, I only need to really plan about 6 minutes. I guess that's pretty fast. Anyway, sorry. So does everyone see how this works? So when we look at our question then, how much longer, how much longer will it take to go 5 miles by bike than by car? So basically what we have to do, right? How much longer means, right, that we're talking about our time and not our distance, right? Because we have miles here. So when we look at our graph, right, we've got 5 miles. So where does, right, how long is my car ride in minutes and how long is my, right, my bike ride in minutes and subtract those, right? So it looks like my bike ride is going to take about 23 minutes minus about 11 minutes. So, right? So it definitely wouldn't take twice as long, right? Because we can see that this is 2, 4, 6, 8, 10, and a little bit, and a little bit. It's about 11 miles difference. If it took twice as long, it would be well, now I'm like, oh, did I mark the wrong one? I thought I had D as the answer, but now I'm like, maybe A is right too. Is that what everyone chose? Yeah. Yeah. Okay. Sorry. I'm glad. So, and I know that the wording is a little confusing, right? It won't take 23 minutes longer, right? But if we subtract the two amounts of time, it's about 11 minutes longer, which means it's about twice as long. So I apologize. That was my bad. So if you answered A, give yourself a point there and just know that I mess up all the time too. Darn it. Sorry. But hopefully you can kind of count. Thanks, Art. Yeah, my bad. Okay. So how do we do on number 4? So number 4, we have another line graph. We just have a single line here. Okay. Oh, this is number 3. Sorry. Just. Sorry, Celeste. Okay. You want to come out? Go out. Are you going out? I can't go out. You're hanging out in here. You want out or not? This is your last chance. Go out. All right. Yeah, you're right. You're right, Celeste. So, hi, Brandon. Um, let's look at this one again. Okay. So, all right. So it's about traveling 5 miles, right? So we're looking at basically this line here. And, right, we can see that the car, right, takes about 9 minutes. And the bike takes about 23 minutes. Okay. So it's a little more than twice as long. So I would say, right, answer D is the best, but answer A is a pretty close second. Because it's about 11 minutes difference between going by car or going by bike. So hopefully that helps a little bit, but yeah, the wording can be confusing. And then here, right, traveling 5 miles by bike will take about half the time than traveling by car. And according to our graph, that would not be the case, right? We know it takes more minutes, right, on the bike to cover that distance than it does the car. So if the lines were switched, maybe, but I could see how that wording is confusing too, because once again, sometimes, right, if your car is in like, rush hour, annoying, like awful traffic, then you probably could go a lot faster on a bike if you had a different route. So anyway, I'm not quite sure where you're feeling confused there, Celeste, but I understand. Okay, so we've got another line graph here. And let's see how you guys did on this one. So, all right. So this one was a little bit challenging, but we're looking for the time periods that sales decreased. And so what this is telling us is, right, so across this whole line here, right, from 1990 to 2012, sorry, just make sure I'm not missing anyone. And just put this in the chat. Okay. So how many time periods did SUV sales decrease? So what does that mean? What does decreasing look like on the line for us to count?
Go down.
Good. And so some of them are like pretty clear decreases. Other times, they're a little bit, but right, we're looking for, and maybe you count that as 1 or 2. Good. let's see what we got. 1, 2, 3, 4, 5, 6. Why did I say 7 was the answer?
It says 7 is the answer. I know. I was looking for,
Yeah.
it's like I saw 6.
1. So you kind of have to count these as 2, right? Because and I'm being really nitpicky here because I had to come up with my own question here for this one because I didn't like the one that they made. But hopefully you can agree that it decreased and then it decreased again. Do you see that? So between 2007 and 2008,
Got it.
it decreased a little bit. And then between 2008 and 2009, there was a dramatic increase. So I guess that would be kind of the nitpicky um, answer. And I'll learn my lesson as a teacher to be like, oh, we gotta like, that would have been kind of a cruel question. Well, I mean, Brandon, I wasn't able to bind it together into a book like the math book, um, which is why I thought I had sent you some more of the language arts materials recently. Um, I want to say like a week or more ago. I'm not quite sure how long. Sometimes it takes a while for the mail person to pick up the stuff, but I feel like I did try to send you all of the language arts materials, the like 5 units that we've been doing. Um, just a sec. Okay. Dang, I don't know why. Um, hmm. Having a students not being able to get on either. Okay. So 7 is the technical answer. And I guess if you had, you only had like 5 and 6, which means I really should have counted like this is 2 as well. So, all right. If anyone was around on last Wednesday, yeah, 7 is the answer for that one. Celeste, so yeah. Did you guys get to scatter plots on Wednesday night? Pretty sure this is where we left off on Monday. All right. Has anyone seen scatter plots?
This is my first time seeing that.
Okay, no problem. Thank you. Okay, Celeste, thank you. All right. So, all right. So a scatter plot is very similar to a line graph in that once again we have, right, a vertical axis and, right, a horizontal axis, and where the data on each axis meets, right, represents, right, a point of data. And so, for example, here, I mean, this experiment would be really hard to do now that I think about it, but here I should have done like people. I couldn't figure it out because I was like, well, I don't want. Anyway, sorry, I should have made this people and not trees. Anyway, so here, right, I am going through the forest and I'm measuring trees' heights and weighing the tree. Okay. And so tree 1 is right here. Right. And so each dot represents one tree in the forest that I chose to measure and weigh. And I am doing that because I think that there is some kind of relationship between height and weight. Okay. And so that's why I'm collecting this data, making them into a point. And the reason why it's a scatter plot is because, right, the dots, I mean, here there's not too many dots, right? I only measured 10 trees, but you know, I'm just a student. I don't have to do like a big project yet. But does everyone understand what the dots represent? And so a scatter plot is basically, I always kind of think about it like, well, if you think about scatter, but if you've ever just like flicked paint right at a wall, or you could kind of think of it as like a shotgun blast, kind of in that, right? You've got lots of kind of holes that you poked. And so the reason that you create a scatter plot is so that you can confirm if there is a relationship between the two variables that you are collecting data on. And so once again, here we'd say someone is interested in trying to figure out if there is a relationship between weight and height. And so they collected weights and heights of 10 trees, right? And put each as a dot on the scatter plot, okay? And so, right, so a scatter plot allows you to get a sense of probably what's going on. So if we look here, we can use the scatter plot to kind of make an educated guess. And so here, right, if the tree's height is 59 inches, what would you expect its weight to be? Okay. And so if we look at, right, if we're right here at 59, right? So if our tree is at this height, where do you think the dot is gonna, where would our dot go along here? Are we gonna have a 59-inch tree that's gonna have a lot of weight based on the other trees that we've looked at? Or is it gonna be a little weight? Where would that dot go? It could go anywhere along this line. Based on the way these dots are kind of, yeah, okay, good, Celeste, you're right. Yeah. So yeah, I mean, it's like the dot is probably going to be, somewhere in between these two dots, right? I was hoping it would let me. Oh yeah. So our speculated tree here, right? Based on our data, we would say, oh, this dot's probably right somewhere between these two dots, which means, right, that based on the height of the trees that I measured in the data I collected, a 59-inch tree is going to weigh between about 100 and 120 pounds. Okay. Now, if this data looked differently, right, we'd have to predict something else. But that's what a scatter plot helps us do, is see relationships. And so, of course, once we can see, right, as the tree's height increases, its weight also increases. Not a lot, but some, right? It's not like a huge dramatic increase. So scatter plots can be used to confirm relationships. And so if the dots are kind of, like I said, it's not like a shotgun where it's like you've just got dots everywhere. Dots everywhere means there's probably no relationship, right? It's like everything's kind of doing its own thing. And the two things you thought were related really aren't, okay? But something like height and weight, right, is usually pretty related if you've done anything in like healthcare, especially like nutrition of any kind, right? Serving sizes should be based on a person's size, weight and height and things. So how does everyone feel pretty good about scatter plots, how to read them, what they're supposed to be showing us? All right, let's look at the last scatter plot problem. Okay, so here you can see that our dots are still showing us a pattern, but they're showing us kind of a different type of pattern. We have a lot more data, right? But when you create a scatter plot and your dots do this is when researchers are like, hooray! Because once again, if there's no pattern to the data they've collected, then that means there's really nothing going on. You basically have to kind of start over, figure out what is related, okay? And so the term that they use, and the term that you might see on the GED test, is this word correlation, okay? And then you hopefully noticed as well that, right, we have positive, yep, good, Celeste, yep, and negative correlations, okay? If the answer were C, right, the data shows no clear correlation, then that would mean, once again, that our dots would just be everywhere, right? They wouldn't be kind of forming this kind of, right, like you said, kind of negative descending line, like you were saying, Celeste. And so here we're looking at the relationship between, right, the right, the amount of the gas bill in dollars. So how much am I paying for heating, right, versus the temperature, okay? And so because we can see, right, my gas bill, right, my heating bill goes down as the temperature increases. And hopefully everyone, I mean, that should be a pretty obvious correlation, unless you're one of those people that has your heat on when it's like over 70 or 80 degrees, right? Definitely, right? When it's 10 degrees, you know, but once again, right, there's less need for that gas to produce the heat. So here we would say, yes, there's a correlation and it's negative, just like Celeste said. It's going down, right? It's decreasing. It's starting high on the left and ending low on the right. So that's what we call a negative correlation. And once again, that means as one variable increases, the other variable decreases, right? As the temperature increases, my gas bill's price decreases, okay? If it was a positive correlation, right, the scattered dots would write ascend or raise. And so it would start low on the left and go high in the right. So you could kind of flip it, right? And you could say, you know, you could put the 0 there, and you could like flip the scales and make a positive correlation, right? That my gas bill increases as the temperature increases. So actually just flip one of these, but here it's negative, okay? If we had maybe like 2 or 3 points of data in our scatter plot, then you'd probably say there's not enough data. Even if it looks like it's patterning, hopefully you would agree that even this one, right, we'd probably want a little more data, right? And when I say that, I mean more dots, right? I need to go back out to the forest and, measure some more trees, okay? I need to gather more people's gas bills, yearly gas bills, and plot them out, okay? And so if there's only a few dots and it kind of looks like there's a relationship, that's when you would say there's really not enough data. But here we've got plenty of data. We've got lots. Questions? Okay. So I wanted to show you another question based on this that I wanted it to be in the warm-up, but it wasn't working. But I wanted to show you one other way that the GED might test you on a scatter plot. Can everyone see the PDF here? I know it's kind of small. Oh, and this is actually our easier one. So that's good. Okay. But remember that, well, and maybe not remember, but the first thing we talked about in our unit 4 on data analysis, right, was that idea of first our data is collected into some kind of table, right? And data is generally numerical values. It might be one value, it might be a pair of values. So once again, here for our scatter plots, right? Because we're connecting a horizontal and a vertical. Thank you, Kayla. Right? It's totally lost my spot, sorry. But good. So does everyone agree with Kayla that table A is the table that of data that created the scatter plot?
I think Ace looks about right.
Good. And so remember that here we have that positive correlation. So that means, right, that as my height increases, my weight also increases. And you see that, right, with your data in table A, right? We start with 55 and 101, right? And as the height gets way up to 65, our weight has also increased to 163. If you look at tables B and C, right, we see that here B is showing that as height increases, weight decreases, which is not what, right, the scatter plot shows. This would be a negative correlation, and it doesn't really make, well, I guess that means that you just get really stout as you're shorter. And then here, what's wrong with C? What did they do? How did the data get messed up in table C?
It's reversed.
What specifically?
The weight and the height.
Good, right? So they took basically the numerical scale for the weight and recorded that in the height row, right? And did the opposite. So that's another thing to always note right away so that you can eliminate an answer and be like, well, wait, there isn't even 101 isn't even on my on my graph for height, right? I guess 58 is, but that's just like this tiny little chunk right here, right? So, pay attention for those things. But really nicely done on that, Kayla. And so hopefully you guys are seeing that connection between pretty much for any graph that we have, excuse me, you're going to start with some kind of table of data. And so you might be asked to answer a question that makes that connection. Okay. Any thoughts or comments about this problem? All righty, good. All right. As I mentioned, I'm not 100% sure who, if anyone was here, sorry, not sure if any of you guys were in class last Wednesday when Katie taught, but if you know where we left off, that would be helpful. Otherwise, I will do my best to try and figure out where we're at. Oh, let me grab the unit here. Okay, page 90. Thank you, Dwight. Perfect. That is okay, Celeste. Thank you, Dwight. Yeah, I was hoping I was going to get a message from Katie, but she actually doesn't work on Monday, so I didn't want to bug her since I already asked her to cover for me on a day that I was taking off. So, okay, cool. Page 90. Just give me one more moment. Okay, so it looks like you did a little bit with scatter plots. And then, okay, and then we had line graphs. Okay. That's kind of interesting that they gave us scatter before line. All right. Okay. Did you guys do um did you guys do problems 3 and 4 at the bottom of page 90? Yeah, scatter plots were just what we were working on, Celeste. All right. Okay. All right. Page 90. Oop. All right. Um, all right, so this is page 90 that you can hopefully see on my screen now. Oh, whoa,
That would be in
hello.
that big old math book, right?
Mm-hmm, mm-hmm.
Okay. Mm.
Now we finally made it there. So once again, right, we have a table of data. And so we are trying to decide, right, is there a relationship between the hours of study and the test score that a person received? So of course we would start by creating some dots. So 24 and 82. Maybe like a dot there. Right, so you're gonna plot all of these. So 7 hours and a big old 47. 16 hours and 53. 27 and 95. Okay, so we're already starting to kind of see, right? There might be a relationship here. 19 hours of study and a 94. Okay. Hopefully you guys can see that. 9 hours of study and a 60. So hopefully you're seeing how, right, in your line graph, you're going to have just like individual dots connected with the line. A scatter plot's going to have hopefully lots of those. Let's see, 23 and 87. 87. 4 and 46. 12 hours and 63. And then 18 and 71. All right. So did everyone see how I use the table to plot, right? Each point on my scatter plot. And now once again, and I'm sorry for my very silly looking dots. I'm embarrassed, but hopefully you guys have enough imagination to be all right. So is there a relationship between a person's test score and the amount of hours that they studied?
It looks like the more they study, the higher their score is.
Yep. So that would be a correlation, right? We're seeing that once again, either they're both increasing together, they're both decreasing together, or right, we get the one is increasing, one is decreasing type pattern. And so, yes, I would agree with Michael. And so usually once you have plotted your data, then you can kind of, and they usually call this just like a guideline. It's not like, but it helps you see, right, where the data, and you kind of have this one guy, did really well, even though he didn't study as much as these guys here. But so any dots that are far away from the line is what we call an outlier, which just means that, oftentimes, especially when people are part of what we're measuring or collecting data on, there's always going to be, right, people that are not in the mold, but most of us are, and it's okay. Probably safe fish. Or, and so, but of course, once again, if our dots were way more spread out, like all across, if we had dots up here and dots everywhere, that's when we know there's not a correlation. Okay. So yes. So for number 4, right, we'd say, yes, there's a odds.
So is there something going to be like this on the GED test? Or
Yes.
we have to build our own scatter?
Um,
Or will it already be built and we just have to answer it like the way you're answering it now?
it might not be, it definitely probably wouldn't be this big. And oftentimes it'll be like partially filled in, and there'll be test items where you'll have to like drag and drop certain numbers into certain parts of the table based on the data.
Mm-hmm.
But it definitely wouldn't be this big, and you definitely wouldn't have to make the plot. Yeah. Um, but it's helpful. But definitely expect to have this kind of what we would call interpretation question, which is always kind of the so what of the graph. And just like you had said really nicely, if we have a scatter plot, generally we're saying as one variable changes, this other variable changes in some way as well. And that's that idea of correlation. And I always think like it's, the word co, right? Like with, and relation. So they're like with a relationship together. Helps me remember that word. So for example, if we look here, right? If I was curious, right? Do you guys feel like is there any correlation between a person's math score and the time it takes them to run a mile? Would we think that those two variables are related?
No.
No. So that would be one, right? If we were hanging out at the trailhead, it was like, hey, what's your math score? And what's your mile run time? Yeah, we probably wouldn't, we might see a correlation, but probably not. But hopefully you agree that the 3 others would, right, have a correlation. Okay. We
Mhm.
already looked at temperature and heating bills, but we could also look at temperature and ice cream sales.
Definitely.
No one's like, hey, we were just skiing all day. Who wants ice cream? Some people are, and I wouldn't judge them, but it is a little weird. And then once again, here, right, the longer you invest your money, you'll, right, earn more interest. And so you would say, right, temperature increasing decreases heating bills, temperature increase, we would assume ice cream sales increase. And so these like, so here, let's just say, no, not.
No correlation.
Right, just so hopefully you guys can remember these terms. Um, And I'm glad, Celeste, that you were making that relationship between the shape of the line, right? If it's rising, it's positive. If
Negative.
it's sending, it's negative. And we're gonna, I mean, if you've learned any linear algebra, you might have already worked on that. Okay, so line graphs. This is page 91. Line graphs are, I would say, easier than scatter plots, but because once again, you have kind of, oh, the last two? The last two were both positive correlations. So once again, we have points of data that then, right, we connect with a line to kind of help us see, right? Showing how a quantity changes over time, okay? So oftentimes, right, each point of data represents a dollar amount in a specific year. And then we have about 8 years worth of data. Can't do math tonight. Oh no, we're in math class. So the line graph at the right shows the gross national income of the United States from 2005 to 2012. And so the gross national income is the total value of goods and services produced by a nation. And so from the graph, you can see that, right, this gross national income figure has mostly increased over time with only one period of decrease. So when very similar to what we were doing as far as using scatter plots to predict or to kind of estimate things, right? We're going to talk about how the change occurred. Okay. And so this would be, right, our kind of our interpretation of the graph, right? Mostly increased, only one period of decrease, right? Which is like we already practiced, right? That downward facing line. Okay. All right. So hopefully everyone feels good about locating information on a line graph. Okay. So go ahead and on page 92, work on questions 5 through 8. Okay. And let me know when you have your answers, please. Okay. Hopefully you guys remember as well, right? So we have up, our up arrow, or if our line goes up, we're increasing. Straight is constant, right? No change. And then right down is our decrease. Excuse me.
Excuse me. I think I'm done.
All right. Anyone else want or need more time on these four? Hopefully they went pretty smoothly. You'd say there's kind of four. Okay, cool. All right. So what did you guys say for number 5? How much greater was the price in February than in January?
40 cents.
Good. Hopefully everyone agrees. Okay. Which period did gasoline remain constant longest?
May through July.
Yep. Good. It was also constant between, right, March and February, but the longest was, yes. Good. And then which periods did it decrease? March to April. Hopefully you guys got this one right. And then a little bit from July to August, a little tiny dip. And then, right, we get those 2 dips from September to November. So you could split it up if you wanted, but I think we can just count this as one. Now that I've already have been called out on that. And then what about the overall change in price?
45 cents.
Good. So we got about, yep, 325. So, yep. Why isn't my brain want to think 35 cents? Yes. Thank you, Art. Good. So line graphs, like you said, pretty straightforward. And of course, if you see multiple lines, then, right, expect to compare. Okay. So now you might be comparing just within one line's worth of data or, right, between multiple lines. Okay. So I want to keep rolling. I feel like we're doing okay and we can do some more practice, but definitely work on the problems that we don't do together on your own. But I want to start looking at the other big piece of this unit that we're going to get into. Okay. And so the first half of unit 4, we focused on kind of visual representations of data and how, we can represent it to show various types of relationships or maybe show that there isn't a relationship, right? And so another way that we deal with data numerically is through what we would call typical values, also known as like measures of center. Okay. And so I want us just to kind of touch base on these ideas. Okay. And so a typical value is an amount that represents the values in a set of numbers. And so, of course, a typical value, therefore, right, it needs to fall within the range of the numbers. And so, depending on what kind of data we have, how much data we have, we kind of have 3 different ways of acquiring the typical value. And so we can represent a typical value as a mean, a median, or a mode. Okay. And all data sets have these typical values that we can find. But once again, we'll kind of learn about situations where one type of typical value is going to be more accurate, representative than another. Okay. And so mean, median, and mode are also on the GED formula sheet. So you don't necessarily have to memorize. But it's kind of interesting because they just mostly give you the definition and not really it's not really like a formula like the other ones on there. But okay, so firstly, okay, Another word for mean is average. Okay, so, whoa, what happened? So if you know how to average a set of numbers, then you know how to find the mean value among those sets of numbers. Okay. And so those two terms are going to get used kind of interchangeably. And so hopefully you can kind of connect those two ideas in your mind. Okay. For a set of values that are similar to each other, the mean is what you want to know when you ask about how much. Okay. Okay. About how much, does an apartment cost to rent in Flagstaff. Okay. So the mean compared to median and mode, the mean is the one that you generally a calculator is going to be super helpful because you have to do calculating, right? And so to find the mean, okay, you're going to add all of the values of the data set together and then divide the sum by the number of values in the set. Okay, how many total points of data do we have? Okay, so like I said, if you've ever calculated an average, then hopefully this will make sense. So for example, right, Ella scored 14, 18, 11, and 16 points in her last 4 basketball games, right? So in the first game, she scored 14. Second game, she scored 18. Third game, she scored 11. Fourth game, she scored 16. So the amount of points that she scored, right, is our data. And we have, right, data from 4 games, okay? And so we want to figure out what is her scoring average. So we start by, right, adding the values in the set. So we're literally, right, adding up the data. Okay. Then, right, we're going to divide the sum, right, or 59, the number we got when we added it up, by the number of values in the set. So how many points of data did we have total? We had 4 points of data. Okay. And so on average, right, we could expect Ella to score about 15 points every game based on, right, her average in the first 4 games. So does that feel familiar and comfortable to most everyone? Hopefully it's not brand new news, but basically what this is telling us is between our 4 numbers, right? 4.75 is like the exact middle point among those numbers. Okay. All right. So oftentimes a mean or an average is going to be a decimal, okay, or represented as a fraction, a mixed number, because we're being very exact, okay? So the mean is not necessarily equal to any number in the set, okay? But, right, it must fall within the range of the numbers in the set. So if you've calculated an average and the number you get after adding your adding step and your dividing step is not, right, is greater than or less than the numbers in your data, you probably made some mistake and you'll need to go back, okay? So just for fun, okay, well, not for fun, but lots of practice here, but just so everyone feels good. Okay. Right. If you're gonna calculate, whoa,
Whoops.
What in the? I just want the calculator. Gosh darn it. Why do they do this to me? Okay, there we go. I'm like, come on. All right, so just for fun, if we have the number 5, if we have, right, I'm looking at this data set right here. Right, so I have 3, right, 3 points of data, 5. So I add them up, 5 plus 4 plus 12. So that is, right, 21. And then I have 1, 2, 3 points of data. So the average of 5, 4, and 12 is 7. Okay.
Yeah.
So I'd say for me, it's always remembering that what number to divide by once you've done your adding, that can be kind of the most challenging. So always just asking yourself, how many numbers did I add? And that number is what I divide my total by. Okay. So I'm assuming everyone's still feeling good about finding the mean. Okay. If you're given a set of numbers, hopefully you can find the mean or you can average those numbers.
Can you do
Okay.
the mean for one of the more difficult ones? Like
Sure.
that dollar sign one?
Like
Yeah, that one.
this one. Okay. And you're just basically, I don't know if you've ever had to use a handheld register, but yeah, so let's see what we got here. So we got $1.25 plus $2.08 plus 97 cents plus $3.12 plus $1.48. And so I add up and I had, right, 1, 2, 3, 4, 5 values, right?
Mm-hmm.
So then I take that and divide it by 5. And so the average is $1.78.
Oh my gosh, I got something else.
Did you just bump something funky in your
I think
calculator
so,
or
yeah. I totally think so.
good job, George? So yeah, and I mean that's the other challenge with definitely and as a teacher, uh these look like grades here. We average grades all the time, right? So it's like if you got bad grades, then you have to get really good grades, right? If you got really good grades, maybe you can get one, kind of not so good grade and still be okay, right? Um, so, but good question. And all of the answers to these problems are in the back of the book. But I wanted you guys to get a sense of that. All right. We'll come back to this. But I think this is page 94. Is it so? Sorry, no, we're way on. I want just really fast look at page 95 here. Like I said, we're kind of doing a little bit of a rush. Oh, because I forgot to ask. How many of you guys are going to be available for class on Wednesday night? I know it's Wednesday before Thanksgiving, so I don't want anyone to feel like you have to come to class. And if most people weren't going to be around, then I was just going to do kind of just some bonus kind of extra work instead of moving on. But if everyone feels like you're going to be around, we'll just have our regular class and move on. But yeah, I mean, Kayla, like I said, if you want to be with your family or if you have other stuff to do, I just technically, right, the college is open and everything. So I wanted people to feel like they
I'll be
could.
doing all my turkey day prepping during the afternoon, so I'll definitely be here.
Okay. Okay. Well, like I said, it seemed like most of the morning class folks were thinking that they probably weren't gonna, be there. So probably just on Wednesday for Wednesday's class, if you can come, but you're not gonna miss any of the big lesson that we're working on right now. Okay, is what I'll say for now. Oh, nice, Celeste. I did too. That's why I was gone last week. But all right, so really fast in the last 5 minutes of class, and of course we'll come back to this on Monday, but because like I've been saying about a lot of what we've touched on, especially recently, median and mode aren't really hard once you know what it is. And so once again, these are questions that I think we can be pretty confident that you can get right as long as you know what it's asking you to do. Okay, so we talked about these typical values in our data. And so the mean or the average is usually the most common way that we try and figure out, right? What is that exact middle? But sometimes we use the median, okay? And so the median is the middle value of a set of data. So differently from the mean, which was that exact 14.75 data that we had, right? The median is going to come from one of the numbers of data that we've collected. Okay. And so in order to find the median of a data set, you first have to sort the data from least to greatest. So you can kind of see that we started with, right, just kind of a jumble of numbers, 40, 10, 140, 35, 30. And so my first step is to sort. Okay. Sort the numbers. Okay. For an odd value of numbers, the number that's in the exact middle, right? Like 35 is, right? There's two numbers on that side. There's two numbers on that side. So 35 is the exact middle. Of course, now my dog wants back inside. She's like that, right? Then that means that that's the median. Okay. If we have an odd set of numbers, then we find the two middle values. Okay. Okay. So you do have to do a little bit of averaging, but only two numbers if you have an even amount. Okay.
So, meaning if there were six numbers, six set of numbers there,
Mhm.
the two in the middle would be our median, right?
You would take the two numbers in the middle, add them together, and divide them by two. So you take the mean of the two middle numbers.
Oh, okay.
Yeah.
Okay.
So I'm sure we'll get an example of that. But and so then finally, the other one really quickly is the mode. Okay. And mode is the value that occurs most often. So if each of your numbers like up here are all different from each other, then there's no mode. Okay. But sometimes rather than everything kind of centering around a middle point, it's centering around a specific value. Okay. And so if we look here, for example, this restaurant, right, its prices, it has one item for $7.99, three items for $8.99, and two items for $10.99. So we would say usually, right, most of the meals are going to be under $10, right? So the mode kind of helps us figure out what is the most frequent. Okay. Not necessarily what's in the middle, if that makes any kind of sense. All right. So we're going to dive into this more next Monday after the Thanksgiving holiday. Like I said, we will have class on Wednesday, but we'll kind of do something we'll find we'll find something to keep us busy. So does anyone have any lingering questions or concerns before we're done for tonight? Okay. Well, good work tonight. Like I said, go back, work on those problems that we didn't do in class, so that you feel confident about what we've covered. Okay. All right.
You.
Have a great rest of your evening.